Okay, 2017, number 6. A lot going on here. We've got a table of values for x, g of x, and g prime of x. Okay, so when x equals these 6 values, we know what the function g and its derivative g prime equal. We're given information about function h, okay, which is some piecewise linear function. Looks like from -5 to +5. Then it says let f be the function defined by f of x equals cosine of 2x plus e to the sine of x power. All right, so we've got 3 functions in play here, f, g, and h. Let's see. Let g be a differentiable function. The table above gives values of g and its derivative g prime at selected values of x. Okay. Let h be the function whose graph, consisting of 5 line segments, is shown in the figure above. All right. Part A. Find the slope of the line tangent to the graph of f at x equals pi. Okay, so slope of the line tangent is just the value of the derivative of the f function at x equals pi. Okay, so we're interested in taking the derivative of this and then plugging in pi. All right, so first up, let's see, f prime of x. All right, f of x is cosine of 2x. So we're going to have to apply the chain rule here. Derivative of cosine would be negative sine of 2x times the derivative of the 2x, which is 2. Okay, plus derivative of e to the sine x is again a chain. We're going to get back e to the sine x to begin times the derivative of the exponent, the derivative of sine x, which is cosine of x. All right, so there's your derivative. That's going to be good for a point, and then evaluating it at pi is the other point. So I'm going to clean this up just a little bit here. I'm going to write the first term as -2 sine of 2x plus cosine of x e to the sine x. Now that's not necessary. I just do it because I like the way it looks better. All right, and now evaluating at pi, we're going to get -2. That'll become sine of 2 pi plus cosine pi e to the sine of pi. Now, it's my understanding that at this point, you can box that in. You have the correct numeric answer. If you're looking to simplify, this does actually come back pretty nice. Sine of 2 pi is 0. Cosine of pi is -1. Sine of pi is 0 up in the exponent, but e to the 0 is 1. And this actually equals -1 at the end of the day. Okay, but there's your second point for getting the value. 1 point for the derivative, 1 for the value. And again, once you sub in the number, you do not need to simplify on short response. So you can box that in and be done. All right. All right, next up, part B. Let k be the function defined by k of x equals h of f of x. Find k prime of pi. Okay, so k is the composition of functions, h of f of x, and we want to take its derivative. So here we're looking at chain rule. So k prime equals, the outer function here is h, so we're going to get h prime, we're going to leave the f function alone, then we're going to multiply by the derivative of the f function, which we would write as f prime of x. Okay, I'm going to do it like that instead of plugging, the whole ugly f function in. I think this is just a neater way to take the derivative here, just using this notation. Okay, and that's good for a point. Now what we need to do is, again, evaluate at x equals pi. So we're going to have h prime f of pi times f prime of pi. Okay. And let's see, we do need to, at a minimum, evaluate this. We got to clean that up at a minimum and also sub in for this thing. Okay, so again, you could just sub this whole thing in over, whoops, let me highlight the right one. You could just sub in this whole value there. Since we cleaned it up, we do know that it equals -1 from before. Okay, but let's figure out what f of pi is. So we're going to go back up to the f function here. That's going to become cos of 2 pi plus e to the sine pi. Okay, the cosine of 2 pi is cosine of 0. That's 1. Sine of pi is 0. E to the 0 is 1. So that actually just equals 2. Okay? So this becomes h prime of 2. You have to get at least that much here. Times f prime of pi. And now let's take a look. What's h prime of 2 going to equal? Well, let's see. H is the graph up here. H prime of 2 is going to be the slope of h at x equals 2. So we just want the slope of that line segment right there. It looks like we're going down 1 over 3. So the h prime of 2 is going to be negative 1/3. H prime of 2, negative 1/3. F prime of pi was negative 1, and so we get a value of 1/3 back. Okay. All right, again, 2 points. One for k prime, one for the value. All right, moving on to part C. Let m be the function defined by m of x equals g of negative 2x times h of x. Find m prime of 2. So, if you think about this question, it's just a lot of play with our different derivative rules. We saw chain rule last. We're actually going to see it again here, but we also have product rule because it's g of x times h of x, so to speak. All right, so kind of just playing off, just that's what this question is. It kind of really just a can you take derivatives kind of question. All right, but let's take a look. M of x is g of negative 2x times h of x. Okay, so we do have the product, and we do have a little bit of a chain here. So let's be careful. M prime of x equals, okay. So we're going to get back. Outer function is g. So g prime of negative 2x times the derivative of the inner function negative 2x negative 2. And because we're doing the product rule, right, it's the derivative of the first function times the second function, plus keep the first function times the derivative of the h function, which we'll write as h prime of x. Okay, so again, a little bit, challenging here. Take your time, be careful. I am going to move this negative 2 in front to clean it up a little bit. And I think we're looking at this. Okay, and that's actually 2 points. They're giving 2 points for the derivative here. So if you messed one of the rules up, you'd get 1 point. Okay, and then they're giving 1 point for the final value. Let's see what m prime of 2 ends up being here. So we get negative 2 times g prime. Let's see, negative 2 times 2 is negative 4 times h of 2 plus g of negative 4 times h prime of 2. All right, so we got negative 2, g prime of negative 4. So now we're going to the g table. G prime of negative 4 is negative 1. H of 2, going to the h graph. Let's see, h of 2, get out of there. H of 2 is that value right there. Okay, so look, I mean, we got if the slope of this line is, whoops, I don't know what I did there. If the slope of this line is negative 1/3, right? If I go down, I'm going down 1/3 over 1. I go down another third over 1. So basically, that value is at negative 2/3. All right, we got to be able to come up with that. So that's negative 2/3. Okay. Plus g of negative 4. Back up to g. G of negative 4 is 5. And h prime of 2. Why does that sound familiar? Where's h prime of 2? Oh, we saw that before. H prime of 2 was negative 1/3. Okay, and again, you don't really need to clean this up. That should be the right answer here, but if we do clean it up, I think we're looking at negative 4/3 minus 5/3 is negative 9/3 is negative 3. Look at that. Okay, and that is the answer. All right. So practice these. They're great problems. Let's take a look at part D before we wrap everything up here. Is there a number C on the closed interval negative 5, 3, such that g prime of c equals negative 4? So usually if they're asking about a derivative equaling a specific value, they're getting at the mean value theorem. So for part D, recall the mean value theorem. If, in this case, G is continuous on the open interval, the closed interval AB, and differentiable on the open interval AB, then there exists a C on the open interval AB. It's really just some X value on the interval AB, such that G prime of C will equal the average rate of change, the average slope of G of B minus G of A over B minus A. So again, if the question is asking to show that a derivative has to equal a certain value on an interval, it's usually getting at this. So in this case, here's A, here's B, okay? Let's take a look at what the average slope of G is on that interval, all right? So average slope of G on the interval -5, -3. So that's going to be G of -3 minus G of -5 over -3 minus -5. Okay, so let's see. Our denominator will be 2. Well, now let's get those values from the table. G of -3. G of -3 is 2. G of -5 is 10. And look at that, right? What are we getting back here? -8 over 2, which of course is -4, right? And that's the value in question. Is there a value on the interval such that G prime of C would equal -4? Yes. Why? Because the average slope is -4. So this is the conclusion of the mean value theorem. So what do we say? Well, we say the following. We just basically need to, there's our work. We've got our slope. That's great. What we need to do is make sure that G holds up to the conditions such that it's continuous and differentiable. So if we go back up to the top here, right, let G be a differentiable function. There's a reason they tell you that. If it's differentiable, it's automatically what else? Continuous. So, we can make the claim, since G is differentiable, it is also continuous. And so, by the mean value theorem, and now you're basically just restating the question. There is a number C on the closed interval such that, basically we're just restating this right here. Okay? Copy and paste. There is a number C on, -5, -3, such that G prime of C equals -4. All right, that's what they're going to want to see, and they're going to want to see this work to go with it. Okay, folks, great question. Practice it, work it out. Shoot me some questions if you have them, and we'll do more soon. Take care.